cave conservation is tricky because they're really fragile systems that left alone do pretty well. There's not a lot to do in a cave system. It's not a place where someone's going to go in and mine something necessarily, although that does happen. Cave systems need as little disturbance as possible. And certainly some disturbance, folks moving through a cave, like a place like Lewis and Clark Caverns, that's a natural cave system. We do our best to minimize impact of the visitors there. And you do that by having designated trails, and you do that by not letting people throw garbage or smoke or, eat. And any of those kinds of things can be really disruptive in a cave system. For the bats in particular, the one conservation effort that's really important is keeping people out of the cave at sensitive times. So bats hibernate during the winter period. If they get woken up continuously, just like any species that hibernates, they exhaust their their fat resources that are intended to get them through the winter.
When is their hibernation season then?
Our bats go in November, and some of them don't come out until May. It depends on a little bit on the weather system and the conditions of the cave itself. But bats can really stay down for a long time, and it's called torpor, and it's really just a state of shutting down their metabolism to a point that they can survive throughout that winter period. They're not using any resources. And then in the spring, when bugs come back out, then they come back out to eat. All of our bats in Montana are insectivorous, so they rely solely on mosquitoes and all the little things that they eat here in the state versus some other places in the world where there's bats that eat fruit or fish or blood or, whatever. So our bats just really rely on that weather system that allows for the bugs to come back out. So again, cave systems and bats have a very sensitive period in the winter in terms of disturbance to the species, so the bats, but cave systems in general can be deteriorated by vandalism. We have some caves in Montana that are filled with spray paint and glow sticks and garbage. And the Northern Rocky Mountain Grotto, the Forest Service, the BLM, a number of partners try each year to limit that sort of disturbance, to clean some of that stuff up. And those sorts of activities are particularly bad for cave systems because, again, they're very delicate and they have a fine balance of moisture and humidity and fungus, et cetera, et cetera. But the biggest thing to conserve caves is really just to keep people responsible or keep people out altogether.
So you would recommend people to cave more in the summer when the bats aren't?
Yeah, so we certainly would advocate that summer is a better time for people to cave because the bats are not in there, with some exception. We could have maternity colonies of bats in a cave during the summer. We're not aware of any of those right now. But the other thing that happens in caves during the summer is bats use them just as a night roost. So there are caves where bats are all year, but they're not in that incredibly sensitive metabolic place. We also know that we have bachelor colonies of bats in the summertime. So all the guys pick a place to hang out for the summer. Again, if they are disturbed, they can go somewhere else. But anytime we disturb wildlife in any period, really, we're causing them to burn resources that maybe they wouldn't otherwise.
And then with the white nose syndrome, could you explain a little bit about what that is?
Yep. So white nose syndrome is the disease caused by the fungus Pseudomyces destructans, otherwise known as PD for short. And that's a fungus that came from Europe. The bats in Europe appear to have adapted better to it and are not impacted like our North American bats have been in the last 15 years or so. Again, the fungus showed up first in New York State. It was detected because of a large bat die-off during the wintertime, because bats appear to be most affected by the fungus during that late hibernation period. They go into the hibernacula with the fungus on their bodies. It has kind of a irritating effect. There's some evidence that it causes some dehydration. It causes a lot of disruption in the body of the bat, which ultimately burns fat reserves. So again, it's a disturbance. In a lot of cases, it wakes the bats up. They have like a mold growing on them. So they wake up to groom. They might go outside and try to find a drink. It's just disrupting that period that's supposed to be very quiet. So that is really the ultimate cause, as far as we know, although the science on white nose syndrome continues to evolve, and there's new information all the time about either how it's affecting bats or how we might be able to treat it. But in general, the disease first detected in 2006 has slowly moved its way across to Montana. Last year, we detected the fungus in a number of eastern Montana counties. We have not detected any bats with the disease at this time. It's likely we might see that this winter.
What does the fungus look like?
The fungus actually looks like what it is described as. It's white nose syndrome. And if you see bats that have literally a mold type substance on their nose or on their wing membranes, it could be white nose syndrome. We have found some individuals during our winter survey period that had what appeared to be a white mold that could have been white nose syndrome, but it ultimately wasn't. Again, these bats are living in these super damp, cool environments during the wintertime where mold likes to grow. So it's not completely unheard of to find a bat. And we did have one a couple of years ago that when the biologists came out of the field, they called and said, "Oh, it looks like we got it." Ultimately, that bat and that fungus was not tied to PD or white nose syndrome.
How do you test to see if it is?
The test for the fungus is a PCR test. You're gonna have to look up what that means because I don't remember. It's basically, molecular sort of exam of the fungus itself. Our winter sampling involves a Q-tip rolled over the nose of the bat, rolled over the wing of the bat, and you'll pick up that fungus even if it's not visible to us, if it's there. So we take that Q-tip, we send it to a lab, and then they run these molecular tests to determine if the fungus is on that Q-tip. Certainly if the disease has progressed to the fact or to the point where a bat is being negatively impacted, you're probably going to see something visible. We haven't found any of that in Montana. Again, in a lot of cases, a big bat die-off might not show any bats with the fungus, but we can test, what's on those bodies, even if we can't see it. And then another way to test that's been developed over the last few years is to actually look for the genetic makeup of the fungus in the guano, so the poop of the bat, because as they groom it off themselves, they swallow it. And it's been determined that you can actually find it after they've deposited it.
That way you don't have to capture the bats. You might be able to.
Right. So we did a lot of that last year. COVID had a big impact on bat sampling in 2020 because we were trying to keep people out of the field and keep people out of vehicles. And in addition to that, bats are mammals. We did not know if we could transmit that coronavirus to bats. And that has not been definitively proven at this time, as far as I know, but it's extremely unlikely that we could actually transmit. One of the ways researchers handle bats and songbirds in particular, or any of the birds, is we often have to look at something under all that hair or feathers. And so we tend to blow on animals. And when you blow on a bird, you move the feathers aside and you can see if she's got a brood patch, meaning she's, on eggs, or for bats, in a lot of cases, you do it to get gender determination. So blowing on things in the spring was particularly unpopular. And so we didn't do a lot of bat handling. We did a lot of guano collection. And so we did have quite a few of our PD detections come from guano, which was, again, the first of our detections of the fungus. In addition to that, we also had positive fungus detections come from swabbing a surface. So if you think about a bat that comes back in the spring, so they're fresh from hibernation, if they had the fungus during hibernation and they survived, they're still carrying it for a little while, up to a couple months. And if you think about a bat that's squeezing into a crack on a bridge, they're going to deposit some of that fungus on that crack as they go through. Staff thus took cotton swabs and they swabbed the sides of those bridges where the bats were roosting, and we also found positive detections of the fungus in that way.
Okay, and that was in eastern Montana?
Eastern Montana, yep, primarily northeastern Montana.
So you don't know if the bats have it because you haven't tested it on them, but you found it on things that they may have touched?
Right, so we know that a bat was there with that fungus, but we didn't find a dead bat. It's pretty common for a place to find the fungus for up to 2 years previous to finding any dead critters.
Oh,
so there's some.
So is it slow? Is it a slow process?
Some science behind that the fungus has to build up in the population and on individuals to a point where it becomes lethal. So they can carry it around for a couple of years before we actually see any carcasses. And then in addition to that, we do know that some bats in the eastern states that were very closely tied to a colony that was completely infected didn't get sick and didn't die. So there's some individual variation in terms of impacts of the fungus to the bat.
Thank you for listening to the Mountains and Mushrooms podcast. The full episode can be found on all the major podcast sites like Apple Podcasts, Google Podcasts, Spotify, Breaker, CastBox, Pocket Cast, Radio Public, and Anchor. Ad-free listening and bonus content can be found at patreon.com/mountainsandmushrooms.